Welcome to JCB EduBuild Solutions. I'm Engineer James Bolowstaff, and today we are analyzing the specific technical parameters of private sewage disposal systems. Code mandates that any building without access to a public sewer line must rely on an approved private system. This setup requires two primary components acting in sequence: a septic tank discharging its effluent into a subsurface disposal field or into one or more seepage pits. A general understanding of how these systems work will not get you through the board exam. You are required to memorize the exact volumetric limits, structural constraints, and spatial clearances dictated by the National Plumbing Code. To build a lasting mental framework for these numbers, we are going to construct a code-compliant private disposal system from the ground up. The transition from raw domestic sewage to safe soil absorption relies on a biphasic flow, anaerobic digestion followed by soil percolation. The code regulates this biological process through strict mathematical boundaries to ensure maximum efficiency. Let's start with the primary treatment component, the septic tank. The enclosure must be completely watertight and constructed of solid, durable materials to resist corrosion. Wooden septic tanks are strictly prohibited. Because it is buried, the tank's cover must be structurally designed to withstand a minimum earth load of 14.4 kilopascals. Internally, the code requires a minimum of two compartments. The primary, or inlet compartment, must hold at least 2/3 of the tank's total capacity, with an absolute minimum of 2 cubic meters. The secondary compartment takes up a maximum of 1/3 of the total capacity, with a minimum of 1 cubic meter. The physical footprint is tightly regulated. The tank must be at least 0.9 meters wide and 1.5 meters long. Inside, the liquid depth cannot drop below 0.6 meters, nor can it exceed 1.8 meters. To maintain proper flow, partitions or baffles between the compartments must extend at least 101.6 millimeters above the liquid level. For access and maintenance, you must provide at least two manholes, each with a minimum dimension of 508 millimeters, positioned over the inlet and outlet. These internal proportions are deliberate. They guarantee enough detention time for anaerobic bacteria to effectively digest solid organic matter before the clarified effluent escapes into the secondary system. This is Table B2, detailing the capacity of septic tanks. Before designing the physical structure, you have to determine the required volume based on the building's specific occupancy. For single-family dwellings, sizing is dictated by the number of bedrooms. A home with 1 or 2 bedrooms requires a minimum septic tank capacity of 2,838 liters. For other building occupancies, sizing detaches from bedroom counts and relies on the maximum drainage fixture units, or DFUs, served by the system. You calculate the total DFUs using Table 7-2, then cross-reference it here to find the baseline liter capacity. Once primary treatment is complete, the effluent moves to the secondary phase. When multiple drain lines are installed in a disposal field, the flow must pass through an approved distribution box to divide the liquid evenly across all lateral lines. If the shear volume of sewage requires more than 152.4 lineal meters of drain pipe for each line, gravity alone isn't enough. You must install a dosing tank equipped with an automatic siphon or pump that discharges every 3 to 4 hours. The trenches themselves follow strict geometry. A disposal field requires a minimum of 14 square meters of trench bottom. Each trench must have a bottom width between 457.2 and 914.4 millimeters, and a single drain line cannot exceed 30.5 meters in length. Drain lines do not sit directly on dirt. They must be placed on a minimum of 304.8 millimeters of clean stone, gravel, or slag. Once laid, the pipe is covered with another 50.8 millimeters of the same filter material to prevent the surrounding earth from clogging the voids. If space restricts a lateral field, seepage pits serve as the alternative. Each pit must be circular in shape with an excavated diameter of no less than 2.2 meters. Regardless of whether you use trenches or pits, the vertical limit is non-negotiable. No excavation can extend within 3 meters of the underground water table. These specific depth, width, and filter requirements guarantee that natural soil percolation can process the remaining bacteria and effluent safely, completing the treatment cycle well before it can compromise domestic groundwater. Domestic sewage follows a standard profile, but commercial or industrial wastes containing excessive grease, garbage, sand, or flammable liquids require intervention. In these cases, an interceptor or clarifier must be installed ahead of the septic tank. This recommended design criteria matrix outlines the specific calculations required. To size an interceptor for a commercial kitchen, you multiply the number of meals per peak hour, the waste flow rate, the retention time, and a storage factor to arrive at the unit's required liquid capacity. Let's pull back to a top-down view of the property. The internal volumes of these components only matter if they are situated correctly relative to the structures around them. This chart, Table B1, dictates the minimum horizontal distances. A septic tank must clear any property line adjoining private property by 1.5 meters. It must also maintain a 3-meter gap from any pressure public water main. The most critical measurements concern public health. A septic tank requires a 15.2-meter separation from any water supply well. Because a disposal field actively leaches effluent into the soil, that clearance doubles to a strict 30.5 meters. When a public sewer line eventually reaches a property, the private system becomes obsolete, triggering mandatory abandonment protocols under the code. First, the existing building sewer that originally fed the private tank must be disconnected, securely plugged or capped within 1.5 meters of the property line. Second, the septic tank or seepage pit must have its contents completely pumped out and properly disposed of. To prevent a subsurface water trap, the structure's bottom must be shattered and the void completely filled with earth, sand, or gravel. The private sewage disposal system operates on strict dependencies. Occupancy volume dictates the tank capacity. Soil porosity dictates the leaching area, and physical clearances guarantee environmental safety. As you prepare for the board exam, continue drilling these numerical thresholds. The code compliance modules demand the absolute recall of every precise capacity, depth, and distance we've covered.